Okay, so the second fundamental theorem of calculus essentially states that the derivative of an integral, including the function x, of the function t, is going to be equal to the function evaluated at x. So essentially, what this means is if, say, we wanted to find the derivative of the square root of 2t plus 9 dt. Well, all we would have to do is plug in x for t. We'd get 2x plus 9. Now, it's a pretty simple concept, but when you have the derivative of a function that is not just x, it gets a little bit harder. So let's say from 2 to x cubed of sine of t dt. Now, normally so like always, we plug in the sine of, we plug in x for t, so sine of x cubed, but we also have to multiply by the derivative of x cubed, which is going to equal 2x squared, or 3x squared. So that's the sine of x cubed times 3x squared. Then, what if we were to do the reverse? For example, d over dx 2 to x cubed of sine t dt. This is just like this one, except these two are reversed. Well, if we were to when we evaluate this, all we have to do is simply put a negative sign for our answer. So just like in this one, we'd get the value sine of x cubed times 3x squared, but we'd have to make it negative. Now, when doing these problems, constants all go to 0. That's why this 0 and this 2 have no effect. I could change this to 3, and our answer would be exactly the same. Now, if we want to do the derivative for x cubed of sine of t dt, and we wanted to bring it up to x, well, now we have to consider the fact that we have 2. And we almost apply the first FTC, in the fact that we subtract f of x evaluated at here and here. Pretty much what it means is we do sine of x times the derivative of x, which is just 1, minus this answer, sine of x cubed times the derivative of x cubed, which is 3x squared.